It's the 16th of May 1968, and emergency workers are attending a strange event in Canning Town, Newham, East London. The call for the London Ambulance, London Fire Brigade and Met Police is to a brand new apartment block. At only 3 months old, the building is not yet fully occupied. The residents here are housed by the local council, and the type of building they are in has been considered a golden bullet of social housing. The call out is to Ronan Point, and it has partially collapsed. The event would change the attitudes towards prefabricated concrete high-rises in the UK, a common sight along the city's skyline during the period known as the post-war baby boom. My name is John, and today we'll be looking at the Ronan Point disaster. Background. Our story starts 20 years before, and a problem for the post-war British society. Housing. Most cities across the country had felt the wrath of German bombing raids, with thousands of houses damaged beyond repair. Much of the inner city housing was Victorian 2-up, 2-down terraces, a hangover from the notorious slums which had filled Dickens' novels. They were at the time considered undesirable and an ineffective use of space. Now just piles of bomb-damaged rubble, many local authorities saw this as an opportunity to carve out a new and futuristic urban utopia. Many councils thought about a possible remedy. How about moving people away from the cramped Victorian slums and into new spacious estates? Well, where does one find space to build? Instead of long rows of terrace houses, architects looked to go up rather than out. If planned correctly, high-rise blocks could have similar square footage to a small terrace house. And once all the garden space is taken away to be replaced with communal areas, the overall space available to residents would actually be greater. The new towers were to be easy and quick to make due to prefabricated building methods, and thus able to transform social housing stock to a community and socially focused ideal. Things like streets in the sky were envisioned as a modern take on the old-fashioned neighbourhood community feeling. This was the era that fostered a greater social societal safety net, such as the NHS and nationalised British Rail after all. I suppose the optimistic feeling must have blinded architects to the nightmares this type of social housing would turn into. When it was discovered that tower blocks, enclosed walkways and open spaces that separated them would become a breeding ground for crime. Anyways, this utilitarian design style was called brutalism and would become a hallmark of British design in the 1950s and 1960s. The Essex town of Harlow would welcome the UK's first residential tower block in 1951, and many more throughout the country for the next 10 to 15 years would be thrown up. The cheapness and ease of construction found its way to a new residential estate in Newham, East London. Ronan Point. Newham Council was birthed in 1965. It was the result of a menage a trois of 3 previously independent county boroughs: East Ham, West Ham and Woolwich. The new local authority completely enveloped East and West Ham, but only a part of Woolwich in the form of the borough north of the River Thames, which is around here on a map. The brand spanking new borough, although still in its packaging box, had old problems. Housing. It had roughly 9,000 people on the waiting list for social accommodation. As such, it sought out to try and solve this new problem with new housing projects. Many, roughly a quarter of the borough's housing stock had been bomb damaged, with its remaining not meeting modern standards. Many had no running water and electricity. Rather than retrofit, demolition and reconstruction was the plan. Up to the 1960s, much of the council's construction projects were of 2-storey houses and 3-storey flat blocks. Well built and utilitarian, they were good but required skill to build them, and that was lacking in the country. The skill drain can be traced back to the war, where many of the previous generation bricklayers, carpenters and builders were lost. Just look at post-war houses to pre-war houses. Gone were the bay windows and ornate woodwork. For example, my house is a pre-war construction. A new, radical and easy to build method was required. The problem wasn't unique and, as we saw earlier, had been apparently solved with the implementation of high-rise buildings. The council's architects looked at two prefabricated concrete building systems, one by French engineer Raymond Camus and another by Danish civil engineering company Larsen & Nielsen. Both systems made use of off-site prefabricated concrete panels to be slotted in together, much like a store-bought garden storage cabinet. This was called large panel system building. Out of the two methods, the Larsen & Nielsen system made use of the least amount of skilled labour. To use the system for the new development, the council had to work with the UK licence holder, Taylor, Woodrow and Anglian Limited. Now there was actually a financial benefit to building as tall blocks as possible. This came about from the Housing Act of 1956, which introduced subsidies to local councils for every floor that was built above 5 stories tall. Taylor, Woodrow and Anglian insisted on using a structural engineer called Phillips Consultants Limited, a wholly owned subsidiary of Taylor, Woodrow and Anglian. To add further conflict to interest, Phillips were hired for the design and construction of the foundations, solely by Newham Council, but were employed by Taylor, Woodrow and Anglian directly for the actual building construction. The contract for 9 blocks was set at £5 million, roughly £500,000 per tower. Ronan Point was to be the second building in this contract. The tower was to be 200 feet tall and contain 110 flats over 22 floors, and was built upon parking areas below. Each flat had a number of mod cons, including underfloor heating, gas, running water and electricity. The structure relies on load-bearing concrete panels. These consist of spine walls that make the main corridor. In addition to these, a number of cross walls at right angles to them and the flank walls that form the end faces of the tower block. The jointing between panels and floors is fundamental to the integrity of the structure. Each load-bearing wall is 8 feet high, roughly 1 story high, 9 feet wide and between 6 and 7 inches thick, and are factory made of solid concrete. The floors are built of precast concrete slabs, each, except for the corridor floors, about 13 to 15 feet long. They are also 9 feet wide and around 7 inches thick. Unlike the walls, these are reinforced and are lightened by a number of circular cores. To keep the whole structure together, a number of types of joints were employed. Vertical joints between the adjoining walls use overlapping U-shaped steel rods, which a vertical steel rod is threaded. The whole joint is then concreted in situ. The horizontal joints between floor slabs, the space between adjoining slabs, is filled with in situ concrete, into which a short steel rod is placed over the supports. The horizontal joints in the load-bearing walls at floor level have nibs projecting from their ends that rest upon the shelf near the top of the wall panels, and the space between the ends of the opposing floor slabs is also filled with in situ concrete. Metal tie plates are at intervals along these joints to help tie the floor slabs to the lower wall panels. When done correctly, all these joints should ensure a strong and stable building. It would take Taylor, Woodrow and Anglian roughly 2 years from start to final handover to complete Ronan Point. The council took control of the tower on the 25th of March 1968 and immediately started welcoming residents into the new high-rise slice of living. Even though we consider them ugly now, the novelty of living up high in the sky drew a lot of people to the tower blocks. But this dream couldn't stay up in the clouds for long. Quite literally. The disaster. It is 5:45 a.m. on the 16th of May 1968. Ronan Point has only been open to residents for roughly 2 months, and the occupant of corner flat 90 on the 18th floor has got up to put on her slippers and dressing gown and went into the kitchen to start filling her kettle to make a cup of tea. The resident of the flat is Ivy Hodge. She lit a match to light her stove. The spark ignited a gas explosion. Hodge was blown across the room. In a later statement, she would recall, "I do not remember any more until I was on the floor, looking at flames on the ceiling." The explosion blew out flat 90's flanking walls, which was supporting the weight of the floors above it. This resulted in a progressive collapse of the southeast wing of Ronan Point. 4 were killed instantly in the collapse. Luckily, due to the time of day that the explosion happened, most residents were still in their bedrooms. And, as the southeast corner consisted mainly of living rooms, most were safely asleep away from the danger zone. Also, in a stroke of luck, 3 of the 4 flats immediately above Hodges were unoccupied, further reducing casualties. On the night of the explosion, there were 260 people inside the building, and on top of the deaths, 17 were injured. Residents were evacuated and the block was closed to the public. Many of the inhabitants were rehomed in another tower block about half a mile away. But how did this new block of flats fail so catastrophically, especially from a gas explosion, which could always be a possibility? Due to the numbers of other buildings constructed in a similar way, the UK government understandably wanted to discover how Ronan Point could have failed. They commissioned an inquiry led by Hugh Griffiths QC. Well, they would find some worrying shortcuts made during Ronan Point's design and construction. The cause. The investigation initially looked at naturally what caused the explosion. It was discovered that Hodge had, upon moving in, bought a new stove with her. This gas appliance was installed by a friend as a favour. The investigation found that the installation was acceptable, although eventually a nut used to connect the gas line to the oven had failed and thus caused the explosion. But the main issue was, how did Ronan Point not survive the explosion? Even the investigation stated this. The explosion was not of exceptional violence. The pressure produced were in the order of 3 to 12 pounds per square inch. This is within the normal range of domestic gas explosions. The root cause had to be in Ronan Point's construction. Well, it wouldn't take long for investigators to find that the tower design was less than satisfactory. It was discovered that the building had not been designed to withstand a progressive collapse, but it wasn't required to in the regulations at the time. The building regulations and codes of practice do not take into account the possibility of progressive collapse. Neither did the designers of the building. The inquiry, however, didn't say that there were any issues with the workmanship at Ronan Point, and as such thought that the tower could be rebuilt, re-strengthened and put back into use. The inquiry put the blame squarely at the outdated building regulations, which seemed to have not considered progressive collapse a thing. This thinking was based on earlier tall buildings, being made out of reinforced concrete and steel frames, which are much less susceptible to a house of cards-like effect that Ronan Point experienced, due to having multiple redundancies for the load to spread out over. The southeast corner of Ronan Point was rebuilt as a new section of apartments, then joined to the existing building via a series of walkways. Many would refuse to move back into Ronan Point and instead be rehoused throughout the borough. The event definitely worried the wider public to the risks of high-rise flats. Enter architect Sam Webb, someone who I think might pop up again on this channel in the future. He became interested in Ronan Point and started investigations of his own. Residents allowed him into their flats to inspect the overall quality of the building, and it was not good. He found that Ronan Point swayed up to 150 millimetres from the centre line in high winds, excessively loading the building, which could eventually cause one of the vital bolts to fail. Webb gave the reinforced Ronan Point at best 15 more years before a total collapse could occur. After years of convincing the council, it eventually evacuated the building in 1986. Webb somehow managed to get Ronan Point dismantled carefully rather than by the traditional way of blowing up demolition method. This was in order to forensically inspect the tower. It was found that several joints were missing the concrete required to seal the connections. In some cases, rubbish and newspaper was all that was found. Lower load-bearing concrete panels were found to be cracked and multiple bolts were bent beyond comprehension. This resulted in Webb's predictions of 15 years to seem way too optimistic. It's a miracle that Ronan Point was demolished when it did, as just under a year later in October 1987, the Great Storm would hit, an event that would have most likely finished off the tower. The disaster ruined the public's confidence in tower blocks, but hundreds still exist across the country. Just look at many boroughs of London. A 60s or 70s tower block is certainly going to be in view.